Hi, everyone. Thank you for coming. This is the San Francisco MySQL Meetup. Tonight we have Ari Weil from Akiban going to talk to us about some more powerful joins, indexing, some good performance stuff. So our sponsors tonight were hosted by IGN Entertainment, IGN.com. So we're doing the facilities, my time, all that kind of fun, good stuff. Food tonight is by Percona. Ryan, do you want to announce anything? All right. Also sponsoring the event tonight is Continuant. They're working on a new logo for the group, so we have a little bit of our own brand identity. And then finally, our other usual sponsor is O'Reilly. They've got a whole bunch of books for us to raffle off tonight, so we're going to be raffling off 5 or 6 of those. Ari also brought in some USB sticks and some other stuff that we'll be giving away at the end for those that stick around. Next month, Percona is going to be giving a talk about Percona Toolkit, which is kind of the successor to MotKit. Also next month here, the PHP Meetup is having Carrie Che talk about cloud programming. Explicit language, but very entertaining, and you'll learn quite a bit from both of those. As usual, does anybody have any announcements about their looking to be hired, looking to hire, or other community events? Going once, twice. All right. Well, with that, I'm going to go ahead and turn it over to Ari, and we'll get started tonight. Thank you very much.
Okay. Hi, everybody. I'm not used to talking with a microphone, as you can already hear. So if I start shouting, somebody go like that. I'm here to talk to you guys about basically the idea behind Akiban. So Akiban is a startup company. We're based out of Boston. The idea here today is that I'm going to talk to you about denormalization and how Akiban can help you to renormalize for database performance. So let's start. The problem statement. In most databases, schemas become complex. What does that mean? As your schema grows over time, you're going to start adding tables, you'll add columns. Your schema will become more and more complex over time. Data volume grows. You gain users, your users upload content, data volume will get larger, you'll have to manage that size, and ultimately, joins become a bottleneck. So assembling all that data together and presenting it back to the user becomes a real problem for the database and for the application. There's 2 common manifestations of joins. There's SQL joins. They're the kind that you write. They're the kind that you have in SQL. So select something from a table, some kind of join, inner, right, left, straight, whatever, join to another table, and you form effectively a result set. The other kind is application object creations, and that's basically the kind of application join that you would perform by running myriad select statements and then assembling an object in an application. So you may not actually use the word join in SQL, you might not actually use SQL, but ultimately you're joining information together in your application to create an object. In both cases, when performance becomes a problem, one of the easiest and most common things that you can do inside of the database is to denormalize your data structures to solve your problems. Now, throughout this talk, I'm going to talk about the various ways that you can denormalize your database, and then we'll talk about some of the advantages, and then later on some of the disadvantages and how Akiban can help you to overcome the problems with denormalization in general. So let's walk you through what a lot of our design partners, a lot of the customers and companies that we talk to experience as their applications grow. V1, you release your product. You've spent a lot of time modeling the business requirement. You come up with a database design that works. You come up with an application model that works. You put it all together, you send the marketing and sales department out, and you say, guys, go and get us customers. Let's find out if this thing actually has legs. They go out and they start getting customers. People start using your service. Pop the champagne. Everything is going great. After you gain enough users, maybe your application needs to add some features. Some things inside of your database become problematic. Maybe you're seeing a lot of blocking lock activity. Maybe it's latches. Maybe it's a lot of high resource utilization like CPU. But ultimately, one of the easiest things that you can do before you really understand where your business is going, where your database is going to grow, is to denormalize. You can make small changes. So I'll take a column from here, I'll maybe take a few fields from there, we'll make a data structure that makes sense to the application. Maybe it's even just because it's easier for some of your application developers to write the code that they need to write. Maybe after a while, you realize that in the MySQL space, you'll do something that's very, very common. You'll start to replicate your database. So the idea here is that you'll send some of your read traffic to a slave, your write traffic to the master, and you'll get rid of the contention for your read activity by sending the write somewhere else. So maybe you'll denormalize again when you do this. What we see with customers is that at every step along the way, there's always some room for denormalization. There's always a way that you can sort of reshuffle your application objects. Maybe you're going to add a field to a user. Maybe you'll think about your security a little bit differently. But ultimately, you start to progress, you're going to get a little bit more complex. So I don't know if you can see it with this slide, but there's basically going to be a continuum where you grow in complexity and cost as your application grows, as you're forced to implement some of these workarounds to get better performance out of your application. Now, caching is another solution that people typically use. This tends to be a little bit more involved. So you can use things like memcached. Maybe if you're using Ruby, you'll use the caching there. If you're using Drupal, you'll add caching there. There's all sorts of different layers of caching that you can add. One of the challenges when you add caching is that you have to worry about how dynamic your data becomes. How often do your users change their data? If you're a Facebook and people are constantly updating their Facebook status, maybe your content is so dynamic it doesn't make sense to ever cache it. Maybe you can cache it for 5 seconds. Maybe you can cache it for 30. But whatever you can do with caching, you're going to take some of that load away from the database, and you're going to help your reads be more successful. When you actually have to go to the database to select data out, then you're going to make sure that there's less contention and increase the performance of those operations. If caching doesn't really help you at that point, if you've grown beyond it, then sharding becomes another alternative. Now, sharding presents its own challenges and its own benefits. You're splitting reads in this case. So you're going to make sure that, let's say you shard temporally. Maybe you're going to take your time-based data and you're going to put different times on different shards. And that way, when you have users accessing some data, they won't be affecting the users that are accessing different data. If somebody's reporting on historical information, it won't affect the users that are doing more real-time or recent querying. Sharding can be incredibly complex. Your application has to know your sharding. Your DBA has to manage sharding. You have to try to make sure that you don't have any kind of a join that's going to try to take data from one shard and join it to data from another shard, because then your performance optimization has just created a significant bottleneck in your environment. When you get done with all of that, if MySQL isn't doing what you need it to do from a performance perspective, it's time to think outside of the box or outside of the MySQL box. You think about NoSQL solutions, maybe polyglot persistence. That's one of the big buzzwords around big data and cloud and all those other things. Basically just implementing a NoSQL store off to the side. It's appropriate maybe to put some of your information in a separate data store. I heard some people talking about MongoDB. There's a lot of other alternatives out there that are appropriate to take some of your information out of a relational structure and to put into a NoSQL database. But maybe you want to stay fully relational, and at that point you don't know what to do with MySQL, so you start evaluating commercial solutions. Maybe Oracle, maybe DB2, or SQL Server. Now, moving from MySQL to one of those solutions introduces all sorts of challenges as well. You maybe have to change your SQL syntax because the ANSI standard doesn't really provide for all of the customizations that these vendors supply. Maybe you have to go out and hire new people. Do your DBAs know how to work with SQL Server? Do they know how to work with Oracle? I heard there were some Oracle DBAs in the room. Would anybody raise their hand and say that MySQL DBAs are equivalent to Oracle DBAs? No. And some chuckles, understandably so. So let's talk about denormalization. When we tried to look up denormalization to start doing these presentations, it was surprisingly difficult to find a concise and consistent definition of the term. So for my purposes, I'm going to use the third. The process of restructuring a normalized data model to accommodate operational constraints or system limitations. I like that one because it talks about constraints and limitations. Now, denormalization is not always a bad idea. Sometimes it's completely appropriate. But in other cases, you're doing it because you have a problem that you can't otherwise overcome. I need to join this data together. I need to create an object. I need to find some way to do it so that I can have the application response time or meet my service level agreements for my customers, but I can't do it with my fully normalized data structure. So I denormalize. So let's talk about some ways that you would do that. A materialized view is one very, very common alternative for denormalization. Basically what you're doing is taking the results of a query or a set of queries, and you're going to put that into a persistent database object. So whether it's actually a materialized view, or maybe you call it a data mart, maybe you call it a modified star schema, whatever you call it, you're taking a query, you're taking the results of that query, and you're putting it inside of a table. Why would you do that? So let's look at an example. This is from Drupal. Anybody here familiar with Drupal? Anybody here administer Drupal? Anybody here administer the database behind Drupal? All right, fantastic, right in the front. So do you recognize this query? So this is a query that when we were talking to some of the folks that deal with Drupal performance issues all the time, they said is surprisingly one of the number one places where they start to see problems as databases grow. So as you start to add content to your Drupal site, you're going to start growing the size of your node table. And when you have to join node and term node, select a distinct value from the join, limit it by the status and the term node ID, then order that information and limit the top 25, surprisingly, you end up with very, very inconsistent and typically poor performance, especially when you have a lot of users on your site, especially when you have a lot of content in your database. Now, there's actually a project that exists on Launchpad that's specifically designed to overcome this problem in Drupal. It was written by David Strauss. It's called PressFlow. You can look at it under launchpad.net/MV. What he does is to create the following table. So in MySQL, you don't have a true materialized view. There's no such thing in MySQL. In Oracle, you might have something like that. In SQL Server, you have different types of views. DB2 has its own. But a materialized view doesn't actually exist in MySQL. So you create this table. Now, if you look at the columns in the table, it's basically the columns that they need for the majority of the queries against the node table with one column, and I'm definitely too short to reach it, but term underscore TID is the one column they pulled out of the term node table. If we go back to the previous slide, you'll notice that that was the thing that they were using to limit inside of the result set. So if you add it to the materialized view, you're working on the performance of the select. And if you'll notice, the main difference between the previous select and this select is that we're not joining information together. We're selecting all of the data out of a single table. We've eliminated the join. So you've got a slightly simpler SQL statement to run. You've got a materialized view now in your database that's going to hold all the information. And in theory, you're going to overcome the majority of the performance problems in your Drupal database. Now, this does work, obviously, because they've got a project. People write about it. They talk about it at DrupalCon. There's a lot of very large organizations that are using this project. But ultimately, when your database gets big enough, this is going to require some maintenance. So I want to talk about some of the different types of denormalization, the pros and the cons of each. So we talked about materialized views. I'm not going to read the table, don't worry. The next type that I wanted to talk about is storing an object as a blob. So does anybody know what I might be talking about when I'm saying storing an object as a blob? Yeah. Yeah. So typically I'm putting XML inside of a single field, or maybe JSON inside of a single field. Maybe I'm storing an image. I'm not talking about that kind of an object as a blob. But typically it's some kind of a relational structure. My relational structure isn't going to work for a certain type of object, or I don't feel that it's appropriate, so I'm going to put a lot of information inside of a single column. Now, if I'm using XML, let's use that as an example, then if I want to query it, I have to use XPath. If I really want to get any information out of the XML object itself, then I'm going to have to not use SQL, because SQL knows about the column. It doesn't know what's inside the column if it's XML. So I have to use XPath queries to actually find the information inside of that XML document. Who has experience doing that in MySQL? Easy, hard, perform it, not? What was your experience? I'm just curious. So it definitely limits the capabilities inside of your database. What he was saying is it limits your ability to run complex queries, and that's true. It limits what you can do at runtime and just how complex you can make a query against that XML object, because the relational database was not designed to manipulate XML that way. But it's something that works. It's something that they've added to every database. So I used to be a DBA for SQL Server and DB2. We had to deal with it there. Oracle DBAs deal with it. It's one of those things that you just do when you're trying to make a relational database work without using some other form of database off to the side. Denormalizing first normal form. This is what we're talking about here, is basically taking a set of attributes and putting them all inside of a single table. So a common example, and one that we have at a current design partner, is let's say that you have a web property, and every user that signs into that property can have multiple addresses. So you'll look at the amount of data that people have added, you'll look at your user base, you'll look at the use case from your applications, and you'll try to come up with how many different location IDs should I store in a table to make sure that I don't have to join to another table to satisfy my front-end application. So in the case of this one design partner that we have today, they chose 4. And every once in a while somebody needs 5, and they need 6, and maybe they need a few more, but mostly what they're doing is they have 4 different location IDs that every user can have associated with a single record. And after they have a fourth, after the fourth, when they add a fifth, They have to add either another row for that user, or they have to join to another table that hangs off the side where they can hold other location IDs. But it's a good solution if you have a really good idea for how much data you need to associate with one particular row, and you can avoid that join. So there's performance gains to be had. But when your schema expands or when your application expands, in some cases you need to modify that schema if this is the way you're denormalizing your database. The next one is second normal form to first normal form. And basically what we're talking about here, the very common case is, let's say that you have to evaluate a user's age before they can get into any content in a website. So as you go to the different tables in your database, you carry that date of birth field and that user ID column through all of your tables. And now, let's say a user decides, well, I wasn't really paying attention when I signed in and I said my birthday was in 1985, I was actually born in 1969. I've got to go in and update all of the different tables where that date of birth field exists. It's not that I'm just updating it in my user table anymore. Now I've got to update it across the database. That might not be a problem, or it might be a big problem. It really depends upon what degree you've taken this to in your database. Now another really common one that we used to do, so I worked for a company, we did application performance management. And we had a front-end application that absolutely had to return any query that the user would run, and we had no idea what they would run, but every single query they would run would have to return within 3 seconds. That was our sort of SLA with the business. So we ended up carrying columns through 10, 12, sometimes 14 tables inside of the database. So by the time you got to that 14th table, our composite key was sometimes bigger than the table itself. And if we had to maintain that data, if we ever had a schema modification, it was a huge challenge. Did it help? Absolutely. You could run any query you wanted. You had no idea as a front-end user that that kind of a mess was going on in the database. And as far as you were concerned, there was no mess. Database upgrades went fine. Everything was great. We had to work really, really hard to support that. But as a denormalization technique, it was fantastic. Now, adding derived columns is another one that people will argue with. People get very passionate about these kinds of things. Is it appropriate? Is it not? When do you use it? To what extent do you use it? A derived column, an easy example of that is, let's say that I have a database that holds employee information. You have a salary, you have a performance bonus, and then after a while you're going to calculate what is that person's salary once you've applied the performance bonus. So instead of calculating it in an application, you'll save that value in a column. Now that's a really trite example. There's a lot more convoluted, complicated, and worthwhile ways that you might do that. But the point is, instead of running a calculation at runtime, you're going to store that information in the database, and then when the application goes to query that information, it's ready. The last one is a property bag. Now, a really common use for a property bag is when, let's say you have an application that scans computers. Maybe it simulates security attacks or something like that. So you're going to attack an organization. You don't really know what you're going to find, but you're going to expose vulnerabilities, and you want to keep track of that so you can provide a result back to the user who's bought your service or bought your application. And so you're going to use a triplet store. So you have an ID, a value, and then some other data that you're going to store in that database. Now that's fine. There's nothing wrong with it, but think about adding an index on top of that. What are you indexing? If I'm storing just a key, a value, and another piece of information about whatever I might find during a scan, what does my index actually hold? I can ID, I can put the ID in the index, maybe I can do the time that I scanned it, but ultimately if I'm looking for the data that was the result of the scan, I could get software, I could get hardware, I could get configuration settings, maybe I'll get information about wireless, but ultimately if I'm creating an index on top of that table, I'm basically indexing something that I don't know anything about. So the degree to which it's useful is really going to depend on A, your use of it, and B, how much data you actually have in there. So for a lot of the organizations that use this, the real sweet spot for using the RDF is keeping the data small or purging it frequently. So you'll run a scan, you have the index, you create the report, you wipe the table and put it in a different store, and then you move on and do it again. In that sort of a use, it works fantastically well, because it's a very flexible structure that you can put inside of a relational database, and it serves that purpose beautifully. Now obviously, I wouldn't be showing you all of these things if we thought that this was the end-all be-all of database performance optimizations. So we're talking about renormalization or joining for free. The idea behind Akiban is that you're able to access information in your database with improved performance without denormalization, and that improved performance is in the order of magnitude from 10 to 100 times. Now it sounds contrived, it sounds like marketing. Of course, it somewhat is marketing, but we've actually seen these results with a lot of our customers, and I'll show you a few examples in this presentation. The other benefit is that you can retrieve an object in a single request. So how many people here work with ORMs? How many people work with Hibernate specifically? When you use Hibernate, have you ever run into the case where you want to select something from one table and the foreign keys start off a triggered effect where it'll just start selecting from every foreign key table? So you're building an object. Again, this is what I was saying before with two different types of joins, one in SQL and one in an application. So Hibernate will join by querying a number of different tables in sequence, and it'll build that object. So one example that people can usually identify with pretty readily is Facebook. If you load up Facebook at some of the busier times, so let's say in the US you're going to pick maybe like a Thursday night or a Friday night when everybody's getting ready to get out and they're all updating their statuses like crazy. If you're in some of the companies that I've worked, that could be just about any time of the day where every 5 seconds somebody's updating their status. But what happens when you log in at that time is what you'll see on the home page, on your home page, is that it doesn't just come up all at once. You'll notice a module here, a square there, a couple lines of text somewhere else, and eventually you have your website that builds the entire page. So what you're doing is you're asynchronously calling the database and you're bringing back the information that you can as quickly as possible. And you're giving the user something to look at as that application is built, as that object is built in the application. So retrieving an object in a single request in that sort of a use could be attractive if you can do it fast enough. And we want to show you how we can actually do it fast enough to satisfy that request. So how does table grouping work? What is it? Is anybody familiar here with Oracle cluster tables? Okay, it's not that. But Oracle cluster tables is sort of a similar idea. Denormalization is a similar idea of how we start to think about it. Inside of a database, you've got a schema. A schema has tables, and tables have columns. With Akiban table grouping, we're inserting groups in between schemas and tables. So essentially, you're saying that inside of my database, I have a table group, and that table group has member tables. So we're joining for free. Any table that exists as a member of a table group has its joins pre-calculated. The joins between those tables are free. Table groups are also first-class citizens in a database. So the idea here is that for DBAs to administer a database, instead of having to administer permissions on a table-by-table basis, or in some cases at an even more granular level, it would be nice if you could set policies or set your roles and security groups at a table grouping level. So people can access my user table or they can't. What can they do on my user table? Can they read it? Can they update it? What kind of a role do you have in the database? Now you can possibly administer it at a higher level. So what does it actually mean? Let's look at an actual database. So this is Drupal again, a very small subset of Drupal. When you start to look at a database for denormalization purposes, the first thing you do is, does anybody think about denormalization in a certain way? What's the first thing you do when you want to denormalize a database? Anybody? No? You look at the joins. You look at what tables do you, is that me? Am I doing that? It's terrible. I'm a shouter, I told you. So when you query certain information out of your database, you're going to frequently access groups of tables together. So if I assemble a user object, maybe I'll get my user table, my permissions table, maybe roles, maybe sessions, but you'll start to see patterns emerge inside of a database. So if you look at Drupal, block and block roles are frequently joined together. Users roles, and sessions are joined together. Node with access, node comment statistic, those are frequently joined together. So if I were to denormalize this database at this point, I'd say, okay, so what columns inside of the database do I frequently want to select out of those tables that I typically join? And then I would create an object that contained all of those columns. If you didn't want to create an actual persistent structure, you might create a view, or you might create a stored procedure. And in some cases, if you have business analysts in your office that need to select the data, it's easier for them to write a query because it's easier for them to understand what data is related and how it's related. If you have developers, in some cases, it's easier if you have a super normalized data structure or it's a very complicated schema. In some cases, it's just easier to manipulate code that doesn't have to access the full relational structure. But either way, when you think about denormalization, this is typically a very common way to think about it. How do I typically access my data? So for table grouping, we look at the relationships and we turn them into groups. So my block group is comprised of the most frequently joined tables related to blocks. The same thing with users and the same thing with nodes. Now if you look at what's left inside of this schema, I've got 3 main groups. They correlate to the most frequently accessed tables in my database. And then I've got one table that remains that I haven't grouped. Table grouping does not require you to group your entire database. In fact, many times it's not appropriate to group your entire database. It's just like when you would create a view. It's just like when you create a stored procedure. There are tables like lookup tables. If you have a database that has, let's say, information about addresses, the state table It's not going to change that dramatically, hopefully. People may secede. Who knows what's going to happen in the next election. But ultimately, you've got 50 some odd states. That's going to stay. If you join to that table, it's not that expensive. You can put that entire table in memory. You don't have to worry about it changing very much. You can cache it, and you don't have to worry about that area of the cache being invalidated. So for those tables, there's no reason to group it. But for the tables that are frequently joined together, we perform this grouping operation to make sure that you can keep your caches populated, that you can more efficiently access data, and ultimately so that your joins are free. So let's look at the way that this looks in a little bit more of an abstract fashion. 3 tables: users, roles, and sessions. We maintain the logical level inside of the database. So my tables remain just as they were before. Thank you. So users, roles, and user sessions, I can still write the SQL against them. They still exist. I can still write all of my security information against them, my database schema operations. They're all going to work against those exact same objects. But underneath, what Akiban actually does is to optimize the storage of that data. So let me take a step back real quick. When you have, if I can click the button once, your logical level, your physical level, and then the way that the data is actually persisted inside of a B tree. So you've got a table. The table's got its rows and columns, and then all of that data is stored inside of a B tree. As I add indexes to those tables, I get more and more B trees, one for every index I create. When I want to join that information together, I have a random access to find my record in one table. Then I'll have another random access to find my data in the other table, and again for the third. Now, as a DBA, I'll create whatever indexes I can to make sure that those operations are as efficient as possible. I'll create indexes along my join keys. I'll create covering indexes for all of the columns I typically select. I'll create ordering indexes for whatever order I would typically select the most expensive operations in. But whatever I do, I still have to maintain physically separate structures. I'm still joining that information together. I still have random accesses as I move from object to object. With grouping, we're consolidating all the B trees into a single B tree. So the big difference between this and denormalization, if we're going to compare and contrast, with denormalization I have a copy of the data in some cases, or I've just created a completely different data structure that required me to modify my database maintenance operations, my application code. Maybe it's not even the greatest thing in the world as far as my business use case is concerned, but it makes the application work the way it needs to work. Usually if I'm denormalizing, I'm either copying data inside of my database, or in some cases I'm exploding data in my database. If we look at the address example, when I have 4 addresses or 4 locations associated with a user, and I spill over to the 5th, I have to copy all of the other information in my users table to get that 5th address ID, or that 5th location ID. It's not that I'm just adding another column. I'm actually duplicating all of that information in the database. If I do it enough, then I have to maintain an awful lot of information that I don't ever intend to do anything with because of the limitations that were imposed by denormalization. With table grouping, not only am I maintaining less data, but when I go to read the information from disk, I have my random access to reach my first record. And then anything else that's associated inside of the group is a sequential access. So I don't have to perform all the additional random accesses. The join is pre-calculated. Now the other nice thing about this is that I don't just have to read my groups from the top down. That would be very limiting. If I just had to create a grouping object that gave me all of my tables in this hierarchical fashion, and we always forced you to read from the top all the way through to the end, then we're not really getting much. We are in some cases, but for the overwhelming majority of cases, we're creating a lot of work where we only have to join, let's say, these 2 tables together. Or maybe there's other tables in my group, and I only want maybe the 7th and 8th table in my group. So you can join any of the tables inside of a table group. We've got pointers inside of our database that are going to maintain the relationships between these tables and make the joins effectively free. Does anybody have any questions at this point? Yeah? So the main difference is that we have a consolidated B tree, and in the case of, let's say you create a materialized view and it's completely separate from your underlying database structures, I also don't have to have any sort of post-processing or other operation that's going to keep that data in sync. Any other questions? Yeah?
To be able to do a join just between the 2 child tables,
Yeah.
you're still using a single group B tree, or is it something a little bit?
We're still using a single group B tree. So the information that we store inside of our storage engine basically maintains a composite key that holds all this information together, and we've got pointers to those keys that help us inside of our own optimizer to make sure that joins like that inside of our group are still going to be as efficient as reading from the outside of the group down. We've got a unique indexing model, so that was the other thing that I wanted to mention. When you create indexes in a traditional database, you're going to index each individual table. When you index a group, you index the entire group. So you're indexing across tables. And you can create however many indexes you want. But the nice thing about the way that we maintain, we call them H keys. These are hierarchical data structures, so H key is we're not terribly creative. You're going to be able to access the information because of the way that we maintain those pointers and the way that we actually have metadata stored for each component of the key. Yeah?
Does that create a lot of memory overhead?
No. So traditionally in databases today anyway, we're asking people, most people are trying to run their databases in main memory anyway. The nice thing about this is actually when you try to cache information from a table group, you're caching the information that you care about. So not an entire index for each table that you were forced to cache normally because that was the most efficient way to get at the data, but we're actually creating indexes on just the object access pattern that you need. And so we're able to actually pull less into memory in most cases than you would for a traditional database join operation. Any other questions? Yes?
How do you deal with a relationship table with many of any join?
So, great question. Right now, we're an early company, and we're trying to work with some of the solutions that people will be able to get their heads around the most quickly. So what we've done are two things. First of all, we're forcing you to create a table group with individual tables expressed once. So if you've grouped it, it's not available for another grouping. So you can't take your user table and add it to 5 different groups. But that's okay, because we're not grouping per query, we're grouping per use case. If you've got a user object that creates all those tables, then you can create a grouping that'll work for 20, 30, 100 different types of queries. It's just that access pattern. It's the use case. Now, from many to many, the problem there is potentially that you'll have a lot of duplication, especially if you look at this picture and you start thinking to yourself, okay, well, I've got a lot of these for a lot of these, so how am I going to create that structure? We're forcing you to group in a single direction right now. So basically, you're going to pick whatever, based on your cardinalities, based on your use cases, based on where your real problem queries are, we're going to tell you to group in that direction. And I'll show you in a bit, when we get towards the end of the presentation, how we can actually overcome, if you think about that and say, well, I actually always have to group in both directions, so that's not helping me. We have ways that you can do that too, and I'll go over those in a bit. Other questions? So the ideas here, I just want to go over them, and then I'm going to show them to you actually with real queries. SQL join operations are fast with grouping. Accessing a group of tables is the same as accessing a single table in a traditional SQL database. And when we say it's as efficient, we're looking at 10 to 100 times performance improvements over your traditional MySQL access. And that's MySQL on Inno, it's MySQL on MyISAM, it's MySQL that's been indexed. We're talking about order of magnitude, let's just say, performance over and above what you normally see out of MySQL. The other thing is that your applications don't have to change. On that previous slide, I mentioned that we maintain the logical level inside of your database. So if you had SQL that would typically join 3 different tables together, you can keep that SQL. We understand that the tables are grouped, and we will access those groups efficiently without you having to modify your SQL. So let's look at an example. We have a design partner. They run an online dating website. They've got 4 million users in 26 countries. They've got, on average, about 60,000 users that are online at any given point in time. In 26 countries, that means they don't have a lot of chance for downtime. Schema modifications are painful. They don't really have an awful lot of options for making sweeping changes in their database. So they have to think long and hard before they modify their database in any event. This is one of their most common queries. It comes off of their homepage, and it's their search. Their search is time and location based. So the people that log into their website want to get instantaneous results based on the people that are closest to them and who is either still online or who is logged on the most recently. When they execute this query in MySQL, they're selecting from 2 tables, they're filtering by 2 tables, they're ordering by the latest login descending, and they're limiting to the top 500 results. That's kind of the way that they guarantee that people won't run this query too often. They get 500 results, that's about 6 pages worth of data for them, so they can make sure that they can sort of stagger the traffic. Now the DBAs have worked really hard on this data structure, and they've denormalized it over the last year 6 times. Okay, so 6 times they've been trying to get the performance of this query to improve. 6 times they've had the business come to them and say, why do we have another sprint that's rolling out that doesn't add any more features? What are you guys doing with the database? Why do you keep pushing out all of this code and we don't see anything from the end user perspective? Well, the reason is, try as they might, as efficient as they can make MySQL, they've got 3 index accesses that result in 2 additional table accesses. That information is then joined together. That join operation at their peak periods, so their peak periods have a tendency to be, believe it or not, Wednesday nights. This kind of concurrency, this is a concurrency killer. So is the temporary table. The temporary table is there both for the sorting operation and for the limiting operation. The sort is performed. If there's enough information that has to be sorted, the sort spills to disk. If there's enough information that has to go in the temporary table gets written to disk, and then the sort occurs as well. These slow operations is what kill them. These operations happen in the single-digit milliseconds in their database consistently. It doesn't really matter how many users they have. We've been using some great tools from the guys at Percona, and we've actually been able to time it. We know that this is great. This is very efficient, and it stays efficient. But based on what's going on with the CPU and the memory on their system at any given point in time in production, they're having problems with the joins, the temporary tables, and the sorts. And then projection, of course, is just sending the results out to the database. Now, we've got the explain plan down here, so you can reference it. Once we table group their schema, the difference that we see is that instead of 3 index accesses, they have 1. Instead of 2 table accesses, they have a single group access. And then they project the results straight out to the application. There's no temporary table required, A, because we've got that group index that we created across the 3 tables. So the data is already ordered. We're reading the data in the correct order. We don't have to put it in a temporary table to limit it because we can stream the information straight out to the application. The result for them was a 27 times performance improvement relative to MySQL. So what we see in the blue line is the MySQL performance. We're graphing how long it takes to run all of the queries that are required for them to render their search results screen. And across the bottom, we were modeling what their user concurrency would look like. So what we used is MySQL slap. MySQL slap was simulating concurrent connections running in a tight loop, which is indicative of, in the case of the 100 concurrent connections in a tight loop, the kind of resource consumption that they saw from 60,000 concurrent users on their website. So looking at it from a MySQL perspective, that's 60,000 users. This is like a Sunday night. Not very busy. But what you can see is as the concurrency increases, MySQL takes longer and longer and longer to run all of the queries that are required to populate that page. With Akiban, we were able to keep that performance nearly flat. So with all of the added user concurrency, because of the fact that we don't have to perform the joins, we don't need the temporary tables, and we don't have the sorts, we don't have all that increased concurrency and contention, and the performance is far greater. Any questions? Did I lose anybody? I don't see any cocked eyebrows. I saw one head shake. No? So let's look at the other example. Object creation query streams. This is the Hibernate example. So I've got 6 tables with foreign keys defined in between them, and I'm populating an object. So one way that I can avoid performing the joins is I can run the 6 individual queries. The overhead here is first in the random access to access each of those tables, second in the network round trips. When I'm running select stars especially, I'm getting back a lot of information that I don't need. Depending on what those tables look like, who knows how big that result set is. But it's still a network round trip no matter how big it is. Running this with Akiban looks like your typical performance killer. We're joining all 6 tables together. But again, they're all grouped together. So in this case, we don't have to perform any of the joins. This is effectively the exact same operation as this. We just joined across UID equals 1387 all the way down the stack. The results in this case is that we were able to create objects at a much faster rate. So on the y-axis, we're looking at the number of object retrievals per second. And across the bottom, again, this is not exactly using MySQL slap because you can't really run it the same way. So we have a modified version of it that we used, and we ran it up to 20 connections in a tight loop. And what you can see here is as you get to the far end of the spectrum, and as you get to those 20 concurrent users, with Akiban we were creating about 57,000 objects per second. With MySQL we were creating about 7. So the performance improvement was substantial. Does anybody have any questions about this? Does anybody have any experience working with queries like this or operations like this, where instead of joining, you were forced to run individual SQL statements? Fair enough. Now, what we're working on are simpler ways to run that same operation. So there's a lot of talk right now in getting away from SQL. Yes, SQL is expressive, and it lets you do a lot of things that you can't do with other languages. There's a lot of power behind the SQL language. There's also a lot of power for you to trip yourself up. If you don't know how to write SQL, or if you're not familiar with the indexing in the database, it's really easy to write yourself a SQL statement that you then scratch your head and go, why in the hell won't this thing perform? So we're going to use something even simpler. You want to get an object? Memcache is great at getting objects. So get put. We'll overload the Memcache protocol. We've actually got working examples of this with our customers. This join was actually done both with SQL and with this Memcache protocol. So what you can see here is get from a schema, starting from an individual table, where an individual column equals a value. So it's considerably overloaded than the usual get from MySQL from Memcache, but the idea is the same. It's a very, very simplified language. It gives you back an entire object in a single request. And, nicely enough, we've got a database now that natively returns JSON. So we can give an application back the JSON format that it was expecting and an entire object in a single request and a single sequential I/O access inside of the database. Now, what we're working on delivering is using the power of SQL because you don't always want all of the information in all of those tables. Hibernate does select stars a lot. Other ORMs do too. Sometimes application developers do it. I worked on some Java applications with people, and they said, who knows what data I'm going to need? Why not just grab it all out? And it's easier for me to write select star because when you go ahead and change the database underneath, I don't have to worry about it. So I've always got all the data inside of those tables. Horrific for a DBA, but that was the way that sometimes it worked. So we've got select of just the information that you want in a nested sort of representation. So I'm going to select just my user ID, my name, date of birth, security information, location, session, profile, preferences. That's all I want out of those tables. If I write it like this with Akiban, we're giving back a nested result set in this case. So working with application developers, we're working on not giving you that tabular representation that you're used to, the array that duplicates a lot of information that databases typically give back, because that's not what the application needs. The application needs to take that array and decompose it into something like JSON. Not necessarily JSON, in some cases it actually is. But they're looking just for that nested representation of the data that they care about to populate an object inside of the application. Questions? So how do we deploy it? The way that we're working with people right now is in the way that creates the least amount of friction in their environment. We don't want you to change your application. We don't want you to massively modify what you do with MySQL. MySQL replication is hugely common. Who here uses MySQL replication? Who here uses it? Well, that's actually not always true, but you never know. Some people just want to know. Who doesn't use replication in this room? That's a much better question. Nobody. Great. So MySQL master is where you send the writes. MySQL reads are going to go over to the slave. We are going to present ourselves as a storage engine to MySQL. Okay? So in this way, with replication, we're going to maintain an up-to-date slave. It's got all the information you need for your reads. With replication as well, you have the freedom to say that you only want to replicate those tables that you have problem queries running on. So Akiban's use case is increasing the performance of queries that run seconds to minutes. That's what we're working on right now. In the full spectrum of SQL, you've got your OLTP, small millisecond queries. You've got your OLAP-style BI, minutes to hours to days queries. We're working on seconds to minutes right now. If you want your queries to run milliseconds to seconds, then that's where Akiban's use case is the strongest at the moment, and we're working on expanding that. So we're working with some people on on-demand reporting, operational reporting. It's carrying us into the minutes boundary, but right now, we're working on really that smaller sort of seconds to milliseconds use case. What we do with replication is allow you to replicate just the tables that you need to create the table group. So if your biggest problem is in a user object, then just replicate the tables you need to form that object, to run those queries. And in that way, your data stays up to date. It works with MySQL replication. It works with all of the other types of add-ons or helpers for MySQL replication. And then we can ensure, using our design partners' typical high availability redirect, you might call it failover, you might call it connection pooling mechanisms, to ensure that there's always some path for the application to take. So the Akiban server can be pooled just like your normal MySQL slaves can be pooled. And if there's any sort of problems inside of the database, let's say with replication, so not in this room, but in some places where we give this talk, people say, I can't use replication because I get errors. And then somebody has to deal with the error until I get an up-to-date slave. So in those cases, we say, okay, so what do you do in your environment? Well, what we tried to do was we pulled the slaves out of the pool. Okay, we can do the same thing with Akiban. That is what we're doing with some companies. I use MySQL proxy. That helps me redirect queries when I'm having a problem in my application, or it just helps me redirect applications when I have reads or writes. We work with MySQL proxy. We've got implementations with PHP code for some users. We've got applications that are running in Java that have the same sort of failover. The idea is the MySQL database slave can be pooled to make sure that you maintain the same high availability that you have with your MySQL slaves. So it's exactly the same idea because it is standard. It's using standard SQL. The queries that you're going to send to Akiban to get the performance improvement, you're going to send directly to Akiban. We're not hijacking the optimizer in this case. We're not changing your MySQL install. We're just installing a storage engine. So you're going to run the normal sort of installation for your storage engine. You're going to run show engines. You're going to see us just next to any other one like InnoDB or MyISAM. And then when you send the queries directly to Akiban, that's where you're going to see the performance improvement. Our optimizer understands that the queries that you send are contained inside of a group, and we're able to provide the same information out of the database that you would normally get out of MySQL, just faster. Does that make sense? Does anybody have any questions about that? Standard. Perfectly standard. Standard. Yep. So statement-based, row-based, mixed mode, if you want to daisy chain us off another slave, all valid. You can use tungsten. I mean, it's just regular replication.
I'm curious what the write overhead is.
The write overhead? So what we've been seeing in a lot of cases that we actually are 2 times faster than MySQL. We're not optimizing for writes, but right now that's what we're seeing. We're definitely keeping up with replication in all cases. In the case of the dating site that we saw, that's hundreds of thousands of operations in most cases on the weekends when they run their maintenance. So keeping up, never a lag relative to another slave.
And the second question is, do you have any optimizations for subqueries, or is it just
We do have optimizations for subqueries. So we've got a team working on the optimizer and working on the use cases that we see. So we've got one customer right now that's using subqueries. We're working with them. So far, we're looking at about a 10 to 12 times performance improvement with them. In some cases, we have people that are on purpose trying to rewrite their SQL. So OJB, does anybody know about that ORM? Does anybody use OJB? So we're working with one customer right now. Apparently, it really loves subqueries. And he's been working on taking any subqueries that are created with OJB and creating those as regular joins. But he misses a lot of them. So the use case there is that our optimization for the joins and the subqueries in that case, which are just another type of join or an in, it depends who you're talking to. On the optimizer team, they look at it like ins. Yeah, the optimization is there, and it works just as well. Another question?
Is the system more performant for ORMs or?
Sorry, is it more performant for?
I mean, ORMs are, my experience with ORMs hasn't been too good. I'd rather have somebody design the database and write the queries rather than have an ORM decide what best to take.
Sure.
Now, I heard a lot of ORM, Hibernate, and others during your talk.
Mm-hmm. It's not designed specifically for ORMs. We find an awful lot of people using ORMs and challenged by the performance that's created or that's degenerated because of the ORM, and that's why we bring it up a lot. It works just as well for handwritten SQL. It works just as well for a database that somebody's tried their hardest to optimize. I won't say that there aren't DBAs out there that can write the most performant queries in the world on the best database structures there are. But there's going to be edge cases for everything, right? So Akiban's use case is that no matter the joins that you're running, we will be able to optimize it relative to MySQL without all of the inordinate steps that you would normally have to take with MySQL. So we've run up against people that have sharded and partitioned and indexed and denormalized, and they've looked at using Percona server, and they've optimized the file system that they're running on, and they have huge amounts of RAM, and MySQL is hugely performant. But every once in a while, they still have an operation or a use case inside of their database that's problematic, and that's where Akiban provides value. In some cases, you can't optimize for every edge case. In some cases, you need to make a schema modification that you weren't planning on, and you're going to have that sort of degraded performance in that area of your application, and that's where Akiban is bringing value today. Yeah?
Your Hibernate example there, it started out with the select star from all those different
Mm-hmm.
tables, and then it switched over to the Akiban, and there was this one statement. How does that happen in hibernate?
So this would be manually changing Hibernate if you wanted to do this.
If you want to do that, you have to write that.
Right. So what we're working on doing next year, so Akiban is an open core model. So we'll be releasing an open source product next year. And what we're doing right now is approaching a lot of different ORM vendors, and we're talking to them about ways that they would like to optimize the way the ORM works. With this sort of a capability and with the ability to deliver the nested result set, what do you want to do with an ORM that you can't today? Or what are your challenges with different databases and different customers that you have? What are they asking you for? And so we're having some really interesting conversations. We'd love to have more. Akiban is also hiring, by the way, but we're also actively looking for design partners. So what we're looking for right now are more interesting use cases and more examples of ways that we can implement this technology with different types of applications. Yes?
Do you have any cost of ownership models that we could look at? For example, I have several clients that only exist during political seasons, and their databases are huge.
Okay.
Because of the data that's stored and the different sources that they come from. But the models may exist for no more than 3 to 6 months.
Okay.
Is it even a solution that may be appropriate in this case?
Sure. Do we have any extensive cost of ownership models? Not really. We're very early. But what I can tell you is what it's like to implement Akiban into an existing stack. So basically, we do package-based installs. So you're going to install the Akiban stack. You can either install it with a single command or two. We've got our own server, and then you've got the adapter that plugs into MySQL. Beyond that, all you do is we change the tables so that your normal create table statement, instead of saying engine equals InnoDB, for example, would say engine equals AkibanDB. And then we create foreign keys inside the database to inform the table structure or the group structure. So those are the only changes that you'll see from a MySQL perspective. With replication, all of your data maintenance is free because replication will take care of anything that you do on the master propagating down to the slave, obviously accepting any errors in replication, but that's not really a cost of ownership for Akiban. And then beyond that's it. The ongoing maintenance, we don't have to run things like analyze and optimize all the time to keep the statistics up to date. We handle that with the adapter ourselves. Your SQL doesn't have to change. Your indexing, you're going to create the group indexes on the queries that you actually run instead of having to try to figure out if the optimizer is using them for joins. So in some cases, it's actually simpler to maintain a table grouped slave than it is to create a standard slave for those types of use cases. Yes?
So the change will be on application integration level, so that when you actually want to select, you should select directly from the Akiban tool?
Correct. So we would create a separate connection pool, and you would use that connection pool to read from the Akiban slaves instead of the MySQL slaves.
And you have several different ones. You have several applications
Yes.
that work with the data different ways.
Okay. So yeah, sorry, I did say I'd get back to that. Because we use replication and because we create slaves, you can actually create purpose-built slaves for the different use cases. So in the many-to-many example, if you were forced to go from left to right with many-to-many, then you'd create one slave for that. And if you really needed to have the right to left, then you would create another slave for that. And so then you have two different slaves that would have grouping optimized for the use case. And that way, the data ownership, again, is the same. Because you're creating the table group, which means all I'm doing is defining my foreign keys in a different order. The replication stays the same. The replicated tables will be the same. And basically all you're doing is enabling that opposite use case. Yes?
Do you see interest in a solution like that mostly from companies who use a prefabricated application like Drupal or some other CMS where they cannot influence the code, or more from companies who are building their own product and still want to optimize the site their architecture?
So we've actually seen both, and in some cases when you write your own application, it's a bit easier to think about this kind of thing because you do interact with the data and the application more frequently. With something like Drupal, especially if you're talking to the people that administer Drupal versus the people that administer the database, as far as they're concerned, the database is just there to hold the content. So they don't think about things like replication. When we have our own independent database stack, so we're working on something for the DrupalCon conference next year where we want to show Akiban with Drupal 7 running on Akiban, so that you have your table group data and you don't have to think about table grouping or replication, and you just make the Drupal performance better. But the answer to your question is really that it's appropriate for both. It's just that it's easier to talk to people that are actively involved in writing the code and writing the SQL because they're already considering these problems. Yes?
Two questions. First,
Yes.
And second question, what about maintenance of your databases, servers? All kinds of maintenance, backup, defragmenting, everything.
So defragmentation we handle ourselves internally. Backup we are currently doing, so there's two ways to do backup. We are doing the cold one at the moment, just because that's the lowest friction one for most organizations to implement. And basically LVM snapshot type backup is what we're doing now. So you copy the data files, and if you want to restore them, you copy them back in. We synchronize our metadata then with MySQL to make sure that we have a consistent set of metadata between the information schema in MySQL and what we call the AIS or the Akiban information schema in our database. But other than that, I mean, there's no index maintenance. Like I said, optimize and analyze, we don't have to run. We do run analyze on the MySQL tables before we create the Akiban groups, just so that process is faster. But beyond that, we maintain the statistics completely ourselves. Whenever you modify anything in the database, so insert, update, delete operations, we're going to maintain the data at that point. Maintain the pointers and the metadata in the B tree.
Any comments with Perform about extra backup?
We have not done anything with extra backup yet. We know we don't do anything with MySQL dump or MyDumper, for example. We don't work on those protocols because it is not a MySQL engine per se. We've got our own stack with a plugin that uses the storage engine API. But the backup, we have our own backup that's enabled by our B tree. So it's a Java stack. The Akiban server is a Java stack. And then our adapter is going to be written in C++ so that it can be plugged into MySQL. But we've got our own Java-based B tree that has a hot backup utility, and we'll be bringing that out either at the end of the year this year or very early next year. Other questions? Yes? Well, right now, we're looking for design partners. And for design partners, there is none. What we're looking for right now is a way to make our technology ready for the masses. So we've got the use cases that we have the interactions with today. So we've been talking to people in advertising and marketing, web-based properties. We've got scholastic use cases, CMS, CRMs. But we're looking for any other type of use case that somebody might have. So when we do come out with pricing next year, we'll make sure to make the rounds and let people know what it is and publish it. But at this point, we don't have a published pricing model. Yes? Well, we're going to be going generally available at the end of the year. So if it's production ready, we have somebody rolling us out into production this month. It is definitely production ready for them. It is not generally available, so it's not generally production ready yet. No.
You say end of the year, what do you mean? End of December, beginning of December?
End of December. It's a Christmas present. Other questions? Yes?
Have you studied what will be the distinction between the core and the paid product?
We haven't exactly determined it yet, and really the reason that we're not open source yet is just because we're resolving some dependencies in the product and making sure that we don't run into any trouble. But no, I mean that's sort of the reason that we're going out and recruiting design partners is to get that feedback now. What we know for sure is that the Akiban server and the parser, the optimizer, the storage B tree, all of that has to be open source because otherwise the product can't function. Beyond that, if there's going to be any features or modules that'll be paid versus free, it really hasn't been determined yet. The goal right now is an early stage open source company. We're looking to have the technology be as bulletproof and as enticing as possible. That's really where our heads are at the moment. So if there's no other questions, we did bring quite a lot of giveaways. So we've got some 4 GB flash drives, we've got some pens, some coasters, just some nice little stuff. If you are interested in being a design partner, or if you just want to get more information on Akiban as we have it becoming available, we've got a newsletter sign-up form. The design partner information is here. Basically, just go to akiban.com. You can't miss the call for design partners. Mark and I have also left our cards on the table. So if you want to talk to us or just consider talking to us later, then please feel free to take one of those. And otherwise, thank you guys very much for your time.